For 60 years, our search for life has been a search for ourselves. We looked for Earth's twin, a rocky world, a nitrogen-oxygen veil, a precise distance from a G-type sun. We called it the Goldilocks Zone, a region where temperature and pressure allow for liquid water on a solid surface. But the universe is rarely so limited by our anthropocentric imagination. While we scan the horizon for Earth 2.0, we overlooked the most common type of planet in the Milky Way, the Sub-Neptune. These are the missing links of planetary science. Larger than Earth, smaller than Neptune, and entirely absent from our own solar system. They are the silent majority of the galaxy, and they are about to rewrite the laws of habitability forever. Welcome to the Hycean world, a portmanteau of hydrogen and ocean. These worlds represent a radical departure from the terrestrial model. On Earth, our atmosphere is a mere 1% of the planet's radius. On a Hycean world, the atmosphere is a massive, hydrogen-rich shroud that can extend thousands of kilometers into space. This hydrogen envelope acts as a powerful greenhouse blanket, trapping heat with incredible efficiency. This allows these worlds to maintain liquid water even at vast distances from their stars, far beyond where Earth would freeze into a tomb of ice. But the diversity is even more startling. We now hypothesize the existence of dark Hyceans, tidally locked worlds where life might thrive only on the permanent night side, shielded from a blistering sun by a global ocean conveyor belt. Even cold Hyceans, wandering the darkness of interstellar space, could harbor life in vast, pressurized oceans kept warm by the radioactive decay of their cores. In 2023, the James Webb Space Telescope turned its infrared eye toward K2-18b, a candidate Hycean world 120 light-years away. What we found was a chemical smoking gun. Through transmission spectroscopy, we detected the presence of methane and carbon dioxide. In an atmosphere dominated by hydrogen, the presence of these oxidized carbon species and the distinct lack of ammonia points toward one staggering conclusion: a massive liquid ocean interacting with the atmosphere. But there was something else, a whisper in the data, a faint signal of dimethyl sulfide, or DMS. On Earth, there is no known natural inorganic process that creates this molecule. It is produced by life, specifically marine phytoplankton. While the scientific community remains cautious, demanding further observation to rule out every possible alternative, the implication remains: we are no longer looking for potential. We are looking for presence. We often assume Earth is the optimum for life, but Earth may be a minimalist environment. Hycean worlds may actually be more habitable. Their oceans can be 10 to 100 times deeper than our own, providing a massive three-dimensional volume of habitable space. On Earth, life is a thin film on a rocky sphere. On a Hycean world, life has an entire abyss to claim. Hydrogen is a superb heat conductor. Because of the high-pressure environment and the chemical energy available at the seafloor, biological evolution on these worlds could be accelerated. Research suggests that on a Hycean world just 10 degrees warmer than Earth, the metabolic rates of organisms could be significantly higher. The time required for complex life to emerge could be cut by billions of years. Earth took 4 billion years to reach this moment. A Hycean world might have done it in 2. If the Hycean hypothesis holds, the number of habitable dots on our stellar map just increased by an order of magnitude. These worlds are not rare outliers. They are the galactic norm. We are moving past the era of wondering if we are alone and into the era of knowing exactly where to look. We are no longer limited to stars like our Sun or planets like our Earth. The universe isn't just a graveyard of cold rock and burning gas. It is an archipelago of oceans, hidden beneath veils of hydrogen. And where there is water and the right chemistry, there is hope. The search continues.